Hello students, today in standard 12 chemistry I am going to discuss one of the very important chapter, that is surface chemistry. Yes students, in this surface chemistry we will discuss about adsorption and absorption at first, and then we will discuss regarding colloids, okay, which you have studied in standard 9. Colloids you have studied. Now, in the beginning, when we will discuss this surface chemistry, we first should know what is this surface chemistry. The branch of chemistry which deals with the surface, with the nature of the surface and the species present on it is known as surface chemistry. The branch of chemistry which deals with the nature of the surface. This is the surface of this particular solid which I have shown, and the branch of solid which deals with the surface, with this surface and the species present in it is known as surface chemistry. Now, to understand this chapter, we'll have to understand adsorption. And what is the difference between adsorption and absorption, that also we'll have to understand. Yes, what is adsorption? What is adsorption? A-D-S-O-R-P-T-I-O-N. Adsorption. It is not absorption. See, it is adsorption. What is this term adsorption? Adsorption means concentration of certain species on the surface of another species. The N in the bulk means certain species like molecules of gases or liquids, if are more concentrated on the surface of some other species, if it is more concentrated on surface of some other species, usually it is solid, okay, then it is known as adsorption. What I am telling? The concentration of some species on the surface of some other species is known as adsorption. Usually what happens, gases or liquids are adsorbed on the surface of solids. Here you see I have shown adsorption. The species or any species molecules are adsorbed on this surface. Now here, to understand adsorption, we will come across two terms. One is adsorbate. What is that? Adsorbate. And another is adsorbent. Adsorbent. See, here the gas or liquid which is adsorbed on the surface of solid, that is known as adsorbate. The substance which is adsorbed on the surface of another substance, that is known as adsorbate. And what is adsorbent? The molecule, the substance or the body in which it is adsorbed, that is known as adsorbent. So I hope all of you have understood what is surface chemistry, the branch of chemistry which deals with the nature of surface and the species present on the surface, that is known as surface chemistry. And what I told, that to understand surface chemistry, at first we will have to understand adsorption. It is different from absorption. Adsorption is absorption of any species on the surface of another species. Here I told you there are two terms, adsorbate and adsorbent. Adsorbate is a substance which is adsorbed, and adsorbent the substance on which it is adsorbed, that is adsorbent. Here we will have to keep it in our mind that it is not a bulk phenomenon. In this, the process In this process, the substance is absorbed only on the surface. Now, we'll discuss this adsorption and absorption. Adsorption and absorption. Absorption. Yes, so we'll discuss this adsorption and absorption in detail. What is adsorption? The phenomenon in which the species of one substance get concentrated on the surface of the another substance, that is known as adsorption. Whereas, what is the meaning of absorption? This we know, that the phenomenon by which the species of one substance get uniformly distributed in the species or in the space another substance, that is known as absorption. So, what is adsorption? Adsorption, species of one substance get concentrated on the surface of the another molecular substance, and it is a phenomenon in which species of one substance get distributed throughout the bulk of the another species, throughout the body of the another species, that is absorption. Means absorption only on the surface is known as absorption, and when absorption takes place throughout the bulk of another substance, it is known as absorption. Now, first point is clear. Next, second we can say it is a surface phenomenon. Since it is being concentrated on the surface of the another species, one substance is concentrated on the surface of the another species. So, it is a surface phenomenon. It is a bulk phenomenon. Next, here concentration is more on the surface, here concentration is uniform throughout the bulk. Concentration is uniform throughout the bulk. It is more on the surface. Then it takes place rapidly in the beginning, and then the rate decreases. The rate is fast. Rate is fast in the beginning, and then it decreases. Here the rate is uniform. Rate is uniform. So, I hope all of you have understood. I am giving one example, student. You see, when water vapor is passed through silica gel, and when water vapor is passed through calcium chloride, what happens when it is passed through silica gel? Silica gel. Silica gel, what does it do? It absorbs water vapor. It absorbs water vapor. It absorbs water vapor on its surface. Silica gel you will be seeing in your water bottles or tiffin box when you are purchasing. Inside that you will find a small white pouch. That pouch you will see that silica gel is written. What is that? What is the role of that pouch? It absorbs the moisture. So there will be no moisture inside your water bottles or tiffin box. So what is the role of this silica gel? It absorbs water vapor or moisture, you can say. Okay. Now calcium chloride. What will be the role of this calcium chloride? If you pass water vapor or moisture, what will happen? It will be absorbed. Okay. So I have given one example of adsorption and absorption. In this case, if you are using silica gel, then it will absorb the water vapor, and if you are using calcium chloride, then it will absorb it. So this is the difference between absorption and adsorption. You can take up many other examples of adsorption. Suppose you are taking carbon monoxide, ammonia in a vessel, and you are keeping some charcoal in it. You will see, if you will measure the pressure at first, and after putting some animal charcoal in it, if you close the vessel and after some time if you take the pressure will get decreased. Why it is decreasing? Yes students, it is decreasing because the gases are being absorbed by this charcoal. Then it is also used, another use of this adsorption you will see in making the sugar, manufacture of sugar. In removing the impurities of sugar, there also charcoal is used. The charcoal absorbs the impurities and it helps in the preparation of sugar. Many other examples you will get. Medicines are also absorbed in our body. Okay, that I will discuss again. Now, here in the beginning we have studied what is absorption, what is adsorption, and what is the difference between the two. Okay. Now you see, before proceeding, we will discuss some of the topic, that is absorption. These are simple topics. Absorption. What is this absorption? Absorption means what? When adsorption and absorption takes place simultaneously, then we say it absorption. Now, you will study two terms. One is positive adsorption. Positive adsorption. And negative adsorption. Positive adsorption and negative adsorption. If in a process of adsorption, the concentration of the species is more, the species which is being absorbed in another substance, in adsorbent, the concentration of the adsorbent is more in the surface than in the bulk, then that is known as positive adsorption. Why? If there is any case in which concentration of the species is more in the bulk than in the surface, then it is known as negative adsorption. So I hope you have understood positive and negative adsorption. In positive adsorption, the concentration of the species is more on the surface than in the bulk, whereas in negative adsorption, concentration of the species is more in the bulk than in the surface. Okay. Now, if there is another term, desorption. Desorption. Yes, student. Opposite of adsorption is desorption. If the particles which are being absorbed that releases from the surface of adsorbent, then that process will be known as desorption. The process of adsorption is the particle in which the particles of one species is being absorbed on the surface of the another species. If in a reaction the opposite reaction takes place, that means the molecules which got adsorbed, they are being released from the adsorbent. They move away from the adsorbent. Then that process is known as desorption. Okay. Now, we'll explain that thermodynamic feasibility. Thermodynamic feasibility of adsorption. Thermodynamic feasibility. See, one question may arise in your mind. What is that question? You may ask that why does this adsorption is taking place? Yes, what happens? If you see the species of any solid or any liquid also, you can see, but more common in solid. You see, I have taken this. In this, a species which is present in the bulk, it is being attracted from all the sides. Okay. So, net attraction force is 0. But the species which is present on the surface, that is being attracted only by this side, by the backward pull. So, it faces an unbalanced force. So, it attracts the species of another species, molecule, another substance on its surface. Now, whenever we are speaking about thermodynamics feasibility, students, we discuss about Gibbs-Helmholtz equation. Yes, you have studied in thermodynamics in standard 11. What is that? That is delta G is equal to delta H minus T delta S. Now, we have studied in thermodynamics that whenever a reaction is spontaneous, delta G is negative. Okay? Delta G is negative. So, for adsorption process also, if the process is what? This process is spontaneous. If adsorption is taking place, then its delta G should be negative. Now, here we spoke that the molecules of gases or liquids are being absorbed by the molecules of solid. So, here delta H is negative. Now you see, what should be the magnitude of delta S? S represents what? Entropy. So, whenever a species is being absorbed, species you see it is moving freely, randomly here. Whenever it is absorbed on the surface of another species, its randomness decreases. So, entropy will also decrease. It will also decrease. So, we should always remember that delta G will be negative whenever delta H will be more than, magnitude of delta H will be more than magnitude of T delta S. Whenever the magnitude of delta H will be more than magnitude of T delta S, then only we will get delta G negative. So, the reaction is spontaneous at low temperature. Low temperature. So, the reaction adsorption is spontaneous at low temperature. So on increase of temperature, the rate of adsorption decreases. Is it clear? Delta G is equal to delta H minus T delta S. I have shown that in this case, the magnitude of enthalpy will be negative, since the particles of one species is being attracted on these particles of the another species. So by the particles of another species, and in attraction there is release of energy, and delta S will be also negative. So if both are negative, then what I told, that the reaction will be feasible whenever the temperature is low, because reaction will be feasible when delta H is more than magnitude of delta H is more than magnitude of T delta S. So this adsorption is an exothermic process, and it takes place at low temperature, and on increase of temperature the rate of adsorption decreases. Now we'll go in detail and we'll study some more things regarding adsorption. Types of adsorption. Types of adsorption. There are two types of adsorption. One is physical adsorption. Physical adsorption. And another is chemical adsorption. Physical adsorption, another is chemical adsorption. Physical adsorption is also known as physioadsorption, and chemical adsorption is also known as chemisorption. So we study here the two types of adsorption in detail. One is physical adsorption, another is chemical adsorption. Now, whenever a gas is being adsorbed in any solid, and in this adsorption process, if weak van der Waals force of attraction is present, we say that physical adsorption takes place. Whenever randomly certain molecules of certain substance get adsorbed on the surface of another substance, and these molecules are being attracted by weak van der Waals forces, then we say that physical adsorption takes place. And what is chemical adsorption? In chemical absorption, real chemical reaction takes place. So there is a real chemical bond between the species of adsorbate and the species of the adsorbent. Adsorbate means the substance which is being adsorbed, and adsorbent means the substance on which this species is adsorbed. So whenever it is being adsorbed by any chemical force, chemical bonding, then we say that it is chemisorption. So whenever a chemical reaction takes place between adsorbate and adsorbent, we say that chemisorption takes place. So here which force is working? Here van der Waals force of attraction. Here real chemical bond exists between adsorbate and adsorbent. Next, some other differences I will speak. It is not specific. Anything can be adsorbed over anything. It is not specific. It is specific, students. It is specific. Okay, because whenever there is a real chemical bond between adsorbate and adsorbent, we say chemisorption takes place. Next, it is multi-layer. Means this adsorption is multi-layer. More than one layer can be formed. Here it is monolayer. Then it is not specific, it is multi-layer, it is specific, it is monolayer. Then it is reversible. It is irreversible. Enthalpy change during adsorption is low. Low enthalpy of adsorption. Low enthalpy of adsorption. Here, high enthalpy of adsorption. Here you will find that the heat change is 20 to 40 kilojoule per mole. Here it will be 82 to 40 kilojoule per mole. So here the enthalpy change during or heat change during adsorption is low. Here it is high. Next, it is not specific, it is multi-layer, it is reversible, it has. Next, we'll speak regarding temperature. We have studied now that during adsorption, energy is released. So, it is an exothermic process. So, energy, heat is released. So, with the rise in temperature, the process of adsorption should decrease. So, we'll say here in physical adsorption decreases with rise in temperature. The process of physisorption decreases with rise in temperature, but here there is some difference. It increases in the beginning. It increases in the beginning and then decreases with rise in temperature. Now, a question arises why it decreases in the beginning and then decreases with rise in temperature, since chemisorption is in chemisorption, chemical reaction takes place, and in a chemical reaction, energy is required as activation energy. So, in the beginning, energy is required as activation energy to start the reaction. So, it decreases with the rise in temperature. Okay.